Hi all, welcome back again to our YouTube channel, and in this video we will study about one of the important applications of KVL in operational amplifier op-amp. So before we begin with, what we know about KVL is to apply the KVL in a given circuit, the given circuit must contain a loop. So it should start from some point and come back at the same point. Then only we can apply KVL. Then we can assign the direction of current and the polarity of the resistors to write the KVL equation. So in this given question, we need to find out, so what is given here? This is operational amplifier with the inverting and non-inverting terminal. And this is differential voltage VD, which is given here, and the output of the amplifier. And these are the two inputs. 5 volt supply is given to the amplifier. We need to basically find out the output voltage in this case. And we also need to check what kind of circuit is this. Is it current amplifier or voltage amplifier as such? So to start with, the first thing we'll do is we'll try to understand the circuit, and it's also given in the circuit that the current passing through these two terminals, input terminal, is 0. So there is no current going into the amplifier. So even though it's not given, ideally the input impedance of an operational amplifier is very high. So it doesn't allow the current to pass through it because it limits the ability of amplifier to amplify the signal given to it. So the current passing through this path will go like this. So there will not be any current flowing in this direction. That's already given in the question, and that's also the ideal characteristic of op-amp. Now the next question is we need to find out the voltage V out. So we have to look where is the loop is being formed. So if we start from this point, let's say A, and go in this way, we can reach till this point. Now this plus to minus can be rewritten as like this, V out. So now you can see, if you start from this point and go this way through 100 ohm resistor, then 470 ohms of resistor, and come back in this path, it's forming a loop. Okay, so finally we got a loop. So now we have all the freedom to apply the KVL in the given circuit. Okay, so start from this point. First let's assign the polarity. So in the direction of current, let's say the current is flowing in this direction. Since the direction is not given, so we will assign the direction of flow of current. And since there is only one voltage, so the direction of current would be in this direction. So here the polarity would be plus to minus and plus to minus. The rest, all the polarities are already given. So let's write down the KVL now. So minus to plus is plus, so plus 5 volt. Now here plus to minus is minus, so 100 times current I. The same current will pass through it because it's given in the question that no current passes through the input terminals, and the VD is also 0. In the question it's given that the differential voltage is 0, VD is 0. That is also the virtual ground concept in the op-amp. So minus 100I, minus 470 times I, and here plus to minus is again minus, so minus V out equals 0. So this is one equation we get from this KVL equation. Now another equation we can apply is here. See, the current would be same and there is no current passing through this. So if we start from this point and after reaching this point, say it B, and coming back this way through plus to minus, and again here it is forming another loop. So we can say that we can replace this VD as a voltage source like this, plus here and minus here. It's given in the question itself, so VD. Okay, and there is no current going here, so you can just remove this for time being. Ideally there shouldn't any current going into the amplifier. So now this is another loop, so we can apply KVL here as well. So if you apply KVL here, it is 5 minus to plus, again minus 100I, and minus VD equals 0. And it's given in the question that VD is 0, so just remove this. So this gives us current equals 5 over 100, that is 1 over 20. amperes. Okay, so we got the current passing through the circuit. Now put this current value here, that will give us the output voltage of the amplifier. So 5 minus 100 and here 470, so total is 570 into 1/20, that is current, equals, let's take it to other side, V out. So if you solve this, V out would be 5 minus 57 by 2, which is 28.5 volt, right? Which is, if you solve it further, it is minus 23.5. So what we are getting here is minus 23.5 volt. So what is the output voltage of operational amplifier in this case is minus 23.5. And what was the voltage we were giving at the input terminal? 5 volt. So 5 volt has been amplified to minus 23.5. So that's why we can say the voltage is amplified. That's why the circuit given here is basically the voltage amplifier circuit. So to conclude, so the idea in this complete question was to understand the KVL, when to apply the KVL. So to apply the KVL, we have to form a loop. So there are two loops in this case, one here and other here. We applied the KVL in both the loops and wrote down the equations. Okay. Now with these two equations, with the first equation we found out the current, put it in the second equation, that gave us the output voltage of the amplifier. Okay, so that's all about today's lecture. Hope you found this video insightful. Stay connected to watch more videos. Thank you so much.